Hi students, in this video class we are going to discuss about decimation in frequency. Last class we have discussed about decimation in time algorithm. In this decimation in time algorithm, what we have discussed is discussed about the derivation concept, and we have discussed about the how to do solve problem in this. Okay, so just I recall this DIT FFT algorithm. Just if an input is given, what we need to do is first we need to find the number of stages. Here the number of stages is calculated from n is equal to 2 power n. So here in this problem 3 is the number of stages, and also input we have to give in a bit reverse order. The same concept here in DIF FFT. The only thing is here we are going to give input in a normal order and we are going to get output in a bit reversal order. That is the difference. In DIT FFT, input in bit reverse order and output in normal order. In DIF FFT, input in normal order and output in the bit reverse order. Similarly, compared to DIT FFT, the first step is to find the sequence. Here they have given the sequence in mathematical relation. So first step is to convert the mathematical relation into sequence by substituting n is equal to 0 up to n minus 1. So here by substituting n value, here we got x of n is equal to 1, 2, 3, 4, 5, 6, 7, 8, and the number of stages n is equal to 2 power n. So 8 equal to 2 power 3, therefore 3 stages of decimation. Now we will see the first stage of decimation. Now in the first stage of decimation, what we need to do is we have to group all the elements as a single group. That is, we have seen the last stage in DIT FFT, right? So this stage we have grouped all the element as a single group and we draw this flow diagram, right? Similarly, we need to draw this for the first stage. So you know how to draw the flow graph for the first stage, right? We have to consider this as a whole group, okay, and we need to draw the flow graph. Here what we need to do is here we need to draw in this first part. These discussions and all we have seen in the theory part, why we are drawing here. So now here that is one, this was x of 0 to x of 3 is as one group, x of 4 to x of 7 as one group. So what we need to do is we need to draw in this order, okay. So 0 to 4, 2 to 6, now 4 to 7, then 5, this 5 to x of 0, x of 6 to here, and this one. Like that we need to draw it, the same flow graph what we have drawn in the last stage, but here we are drawing it in the first. Okay, after drawing this, what we did there, we put minus for the 1/2, right? So here we are going to put minus 1, minus 1, minus 1. So wherever you are having minus 1, there you need to multiply by the twiddle factor, right? So similarly here we are going to multiply with the twiddle factor. Now we need to substitute all these values and we need to find out the final stage of output. We know that W8 power 0 is 1, W8 power 1 is 0.707, 0.707 minus j 0.707, W8 power 2 is j minus j, right? W8 power 3 is minus 0.707 minus j 0.707. Using this value, now I am going to find out the output for this stage. Similarly, if we want to find the output of this stage, for this the input is 1. So here it is 1 plus, it is coming from x of 4. So plus x of 4 value is 5. So it is 1 plus 5 is equal to 6. Here it is coming from x of 2. So x of 1 value is 2. And again it is coming from x of 5. The value is 6, which is equal to 8. Like that you need to fill this in the given order. So now see here, so these and all easy. Now you just you know note down this. So here it is coming from x of 5 6, and also the another input to at this point is x of 1, so it is minus 6 plus 2. So this is multiplied by 2 values, so you just take it as common, then only it is easy for you to simplify like this. So minus 6 plus 2 is minus 4, so just you multiply the coefficient of minus 4 with this, so that you can easily perform this calculation. Now this is what the simplified output for the second stage, simplified output of the first stage, and this is given as an input to the second stage. Now we will see the second stage of decimation. In the second stage of decimation, so first stage here we have grouped as 4. In the second stage we are going to in the first stage we have grouped as 8. In the second stage we are going to group as 4. We are going to draw the flow graph. What we did in the second stages of decimation in the DIT flow graph, so just I will show you now this one. So just what we do, we divide into two groups and we draw the flow graph. The same concept here we are going to do it for this flow graph. Now this is the second stage of decimation. In the second stage of decimation, I have grouped these 8 inputs as two groups, one as 4 and second as another 4. So I have drawn this flow graph. So in the flow graph, next I divided into two halves. So for one part I have substituted minus 1. Another for wherever I have substituted minus 1, I have put that Twiddle factor. So you know that why we are using W8 power 0 and W8 power 2 in this case. Now using the same computation as previous first stage, we will find the output now. Now this is what the computation output of the second stage. Now using this output, we are going to proceed for the third stage. Here we are going to compute a third stage of computation. Here we are going to combine two as an one group. So you know how to draw the flow diagram for two inputs. Now we will see that. Now same as that of previous stages, here I have drawn flow graph for combining two inputs. So for one half I have substituted minus 1, and for that I have used the Twiddle factor W8 power 0. Now we will compute the output of this stage. Now this is what the computed output for the third stage. Now what we need to do is we have to take the output in the bit reverse order. So this bit reverse order, you know, the first one is x of 0, it is x of 4, next one is x of 2, wait 1 second, okay, x of 2, then it is x of 6, next x of 1, then x of 5, then x of 3, and then x of 7. So this we have to take the output in the bit reverse order. Now finally I need to write the output x of k in the normal order. So x of 0 is 36, x of 1 is minus 4 plus j 9.656, x of 2 is minus 4 plus 4j, and x of 3 is minus 4 plus j 1.656. Then x of 3 I have written, x of 4 is minus 4, x of 5 is minus 4 minus j 1.656, and x of 6 is minus 4 minus 4j, and x of 7 is minus 4 minus j 9.656. Now if we want to check, you can check the output, and this x of 1 and x of 7 should be a complex conjugate, and this one both should be, the x of 2 and x of 6 should be complex conjugate, x of 3 and x of 5 are complex conjugate. Okay, so this is the procedure we need to do the DIF FFT. So far we have seen only n is equal to 8. Now we will see how to proceed for n is equal to the same concept. First we need to write down the sequence by substituting different values for n. Here n is capital N is equal to 4. Therefore small n varies from 0, 1 up to 3. So x of n can be obtained by substituting these values. So when you substitute it, what you will get is 1 0 minus 1 0. Now here we need to find the number of stages. N is equal to 2 power n. So here it is 4, you will have 2 stages. So you will have the number of stages 2. Now here in this DIF FFT there are only 2 stages. So because 2 stages because of the n is equal to 4, and also you will have 4 input and 4 input. Now if we have 2 stages, what we need to do is we need to first combine all the inputs. Here we are combining all the inputs means we are having only 4 values. So I am going to combine all the input as once. Okay, so here what I going to do is I am going to draw the flow graph for this. If I have all the inputs, I will do it in this order, combine all the inputs. Now what I will do here, I will write the input in the normal order. So 1 0 minus 1 0, because it is a DIF FFT. And then what I have to do, I have to write down minus 1. Wherever I am having minus 1, I need to write down the twiddle factor, right? So here W of 4 is equal to 1. Here W4 of 1 is equal to minus j. In n is equal to 8, we have used w8 power 0 and w8 power 2, right? So here we are going to choose w4 power 0 and 4 power 1. This already have explained in the flow graph. Okay, so here w4 power 0 is equal to 1 and w4 power 1 is equal to minus j. Okay, now compute this output. So what you will get is, now in this last stage, so this is what the output 0 0 2 0. So in the last stage I need to here it is 4, so here I have to combine as 2. So I am computing, I am drawing the flow graph in this order. Then here I am going to put minus 1. So here it is w4 power 0, here it is w4 power 0, which is equal to 1. Now I am going to compute the output for this stage. So after computation, I got these answers with 0, that is 0 0 2 and 0. So now I need to take this in a bit reverse order. So since it is 4 inputs, so the index is only 2 bits, so 0 0 0 1 1 0 1 1. So the bit reverse order is this. So here this is what your x of 0 now, this is what your x of 2, and this is what your x of 1 and x of 3. Finally what we need to do is we need to write x of k equal to, first one is x of 0. So x of 0 is 0 and x of 1 is 2 and x of 2 is 0 and x of 3 is 0. So this is what the required output. Now we will see the same problem using DIT FFT. So now see the same model for n is equal to 4 for the input 0, 1, 2, 3 in DIT FFT algorithm. In DIT FFT algorithm, the input in the bit reverse order, so 0, 2, 1, 3, and the in DIT first is we need to combine 2 stages. So I have combined two inputs and I have drawn the twiddle that is flow graph here. Then output of is given as the input to this stage. The second stage, here it is 4. If it is third stage, you will combine 8 inputs. So here we are having only 4 inputs. So up to this we will have the flow graph. So the same thing, w4 power 0 and w4 power 1, which is equal to minus j. So finally we got the output like this. So the output will be in the normal order. So finally we got the output in the normal order. Now for tutorial problem, the same problem what we did in DIT FFT, now we are going to do it for DIF FFT. These 3 problem and submit the 6 problem as a tutorial in Genome software. Thank you.